Okay, right. Okay, right. Okay. Now, there is a curve here, right? The blue line. The equation of this curve is y y equals to x squared plus 3. This is the equation of the curve, right? Okay. So I want to find the area between this curve and the x-axis. This is the area. And this area is bounded by two other lines. They are x equals to 0 and x equals to 2. Okay or not? You know which area you want to find? Between the curve and the x-axis. Between x equals to 0 and x equals to 2. Right? Now, you know that this is the area between the curve and the x-axis. So everything you must express in terms of x, right? So at first you will write down integrate y dx, but finally the y you have to change to x according to this equation of the curve. Okay, so finally you have to change to something like this. Everything is in terms of x. Okay, right. So how to do it? What is the formula we use? Integrate y dx. And the y you have to change to this x squared plus 3. So I want to integrate y dx. The y you have to change to x first before you can integrate with respect to x. And the numbers here, they are values of x. That is x0 and x equals to 2. Any question?
No, teacher.
No, huh? No, then we just integrate. X squared becomes x cubed over 3. Integrate 3 becomes 3x. So as usual, you substitute the number 2 inside, then substitute the number 0 inside. How is it like? Finally, it's something like this. 2 cubed over 3 minus 3 times 2 minus 0. The final answer is 8 and 2/3 unit square. Why unit square? Because on the Cartesian plane, you have number 1, 2, 3, 4, 1, 2, 3, 4 on the x-axis and y-axis. So this 1, 2, 3, 4, they are 1 unit, 1 unit, 1 unit. Of course, if it's in cm, then you have cm square. But now we talk about units because we want to refer to the Cartesian plane. So the area is 8 over 2 unit square or square unit. Any question? No question. Okay, no question. Then we look at uh, how to find the area between the curve and the y-axis. If it is between the curve and y-axis, okay, it has to be integrate x dy. It's dy, no? So x dy. Then after that, everything you have to change to in terms of y. You have to change to y. Okay, right. So the question now is, we have a curve. The equation of the curve is x equals to 3y squared plus 2. 3y squared plus 2. So x is the x is the subject of the formula, and the others, they are in terms of y. Okay, and the upper and lower limit comes from the y-axis. You project from the y-axis, y equals to 2 and y equals to 1. Okay, right. So how to find this area, right? Okay. So now you quote the formula. This formula is given in the exam, by the way. This formula is, sorry. By the way, this formula here is given in the exam. Okay, this formula is given in the exam. Integrate x dy. Okay, so if you want to find the area between the curve and the y-axis, you just write down integrate x dy. Just write down x dy first. Then everything that you see, then change to y, right? Everything you see. So I see here a and b. So this a and b, they comes from the y-axis. So y equals to 1 and y equals to 2. And also the function x here, I change it to y, all in terms of y. So it's 3y squared plus 2, then integrate with respect to y. So everything changed to y. So how to integrate 3y squared? 3y squared is 3y cubed over 3, right? So it's 3y cubed over 3, then 2, integrate 2 becomes 2y. Okay, you integrate as usual. The only difference is the variables, they are now y, they are not x anymore. Okay. After that, I substitute in, right, y equals to 2 into this function, and I substitute y equals to 1 into the same function, right? So how much is that? Finally, that is 8, 12. 12 minus 3 is 9, huh? Correct. So answer is 9. Any question?
Now, teacher.
No.